Okay, the first one here. So dNdt, what is that? What is that? What is that? Well, look in there, look in there, look in there. Proportional. Where did they say the word proportional? Oh, there it is. So they say the number of infected computers decreases. So they're talking about a rate of change. So a derivative. And it's proportional to the cube of the number of infected. And the number of infected, that's n. So this is proportional to n cubed. So I get dn over dt is some constant times n cubed. Now, what are my initial conditions? So time is the number of weeks since the update. So they say 1 week after the update, I have 2 million infected computers. So n of 1, I'm just going to write it as 2, where the 2 is understood to be 2 million. What else? What other information? I got this 4. What is this 4 up here? What does that mean? So that's my initial condition, right? 4 million is the amount of infected computers at the exact moment I do my update. So that's n when time is 0 is 4. So here's my IVP right here. Okay, now they want me to solve for n. Do I have to? Yep, okay. So I separate. What do I get? N to the minus 3 dn is equal to k dt. Then you perform an integral on both sides. Here you get n to the minus 2 over minus 2 is kt plus c. Now, using my initial conditions, these two, or just say conditions, I guess, or values, I write down 2 equations. So 2 to the negative 2 over negative 2 is equal to, this is when t is 1, so k plus c. That's using this equation. And then when time is 0, let's give ourselves some more space here. When time is 0, we get 4 to the negative 2 over negative 2 plus c. So from here I get, what is that? Negative 1 over 32 is c. And then from this one, I get negative 1 over 8 is equal to k plus c plus c. So what does that tell me? It tells me k is equal to 1 over 32 minus 1 over 8, which is what? Negative 3 over 32. Yeah. Okay, so I got my c and I got my k. Now I will read the question again. And figure out what I'm trying to do. And part 2, I'm trying to find, just solve for n, right? So maybe this k and c business I should have done later, but it doesn't really matter. I'll do it eventually. So what do I got here? Well, I got 1 over negative 2n squared is equal to kg plus c. I don't know. I'm going to use my k and my c right now. So my k is going to give me this right here. And then minus 1 over 32. Okay, where I plugged in my k that I found earlier, and I plugged in my c. Now, all these fractions are awful, so I'm going to multiply both sides by 32, giving me minus 16 over n squared is minus 3t minus 1. Now, the negatives are unpleasant, so I'll multiply both sides by negative 1. And then I will invert both sides. To get closer to my goal, which is isolating n. And then, again, n squared is 16 over 3t plus 1. Square root both sides. I get n is equal to plus or minus square root 16 over 3t plus 1. Okay, n is a number of infected computers, so I am going to drop the minus possibility. Okay, I can't have negative computers now, can I? Okay. So pause and copy if you haven't done so already. I'm going to sneak a peek at the answer to make sure I didn't screw up. Yeah, good job. Good job, Teach. Okay, part 3. When will there be 1 million? So 1 million, that's an n. So I'm going to plug in n equals 1 and solve for t. Where should I do that? Should I do that here? No, that would be a big expensive time. I'm going to go back instead to actually from here is not bad. So what did I say? When n is 1. So I get 1 over negative 2 is equal to negative 3t over 32 minus 1 over 32. My apologies. I guess I'm using this equation instead, right? I'm going to solve for t. You know what? This is silly. This is silly. I shouldn't do this. I should go. I'm being a very silly person. I should go here. I've already done the work. Why don't I go from here? I'm very sorry. Okay, you should try to do less work. So solving here, I get t is 5. Okay, you want to make your life easier. Choose an equation where t is nice and available, and then go from there.